Okay, dear students, let us see this part. In this video, we are going to discuss about the information related to the radial part of the Schrodinger's wave function, in which we are going to just give the solution of the radial part for particular orbitals or energy states, which are S and P orbitals. So once we solve the radial part of the Schrodinger wave equation, we will come to know that the radial part R, L or NL means it depends on principal quantum number as well as this azimuthal quantum number. And if this is for S and P, if you write these solutions came down. Okay. So this radial part is for an electron in S and P orbitals, how they came with a constant sigma, which is Zr by N A0, in which A0 is Bohr's radius and Z atomic number, we will see here. So R1, 0 if they give in the exam indicates that N is 1 in hydrogen atom and L is 0 for this S orbital. So R1s or R1, 0. Both are same only. In the exam, if they give R1, 0, it indicates that for 1s orbital, this solution of the radial wave function we are writing. That is given like this: 2 into Z by A0 power 3 by 2 e power minus sigma by 2 is a constant here, sigma we have mentioned. Similarly, for 2s orbital R2, 0 they will give, and it will be given 2 power minus 3 by 2 Z by A0 power 3 by 2 minus sigma into e power minus sigma by 2 is the solution came. Whereas for 2p orbital R2, 1 we will write, or R2p we will write. It is 1 by 2. 1 by 2 root 6 is there. That we wrote as 2 power minus 1, 6 power 1 minus 1 by 2. Z by A0 into 3 by 2, sigma e power minus sigma by 2. These are the solutions came for this radial part of the wave function. Using these kind of solutions, we are going to try writing the graphical representations of the wave function from the nucleus. What is the distance, that is r, as well as for the radial function r on the y-axis. So we will take r on capital R on the y-axis and the radius on the x-axis by writing the graphical representations, how the curves came and all, we will check it. See, dear students, now we are going to observe this graphical representations from the mathematical solutions obtained. That graphical representations we are writing, it indicates that this radial part of this wave function is how it is related with the distance from the nucleus. Means we are talking about this electron behavior. That means electron in the hydrogen atom. So if it is hydrogen atom, you consider this RNL is nothing but wave function, and between this wave function and the radius, if you write this graphical representations, taking the r value on the y-axis and capital R value on the y-axis means wave function, and radius on the x-axis, we observe the graphical representations like this. In this, R1, 0 indicates it is 1s orbital, where n value is 1, L value is 0. The graph came like this, the curve came like this. And coming to another graph here, if you see, this is R2, 0. It is a 2s orbital. For this n value is 2, means principal quantum number value is 2 and L value is 0. Coming to the another one here, if you see, R3, 0 is nothing but this 3s orbitals related wave function taken on y-axis. On x-axis we have taken the radius and we got the curve like this. Observing all these things, what is the R maximum is there? At R maximum, capital R max means wave function value is becoming maximum here at these points, at maximum point of the wave function, if you see what is there on the x-axis, the radius is 0. Can you accept this information from this graphical representations? Means obviously your answer is no. Why? Because the probability density of finding the electron at radius 0 means is nucleus. In the nucleus electron is present means you can't accept that one. That means these graphical representations need to be modified. These are the graphical representations we obtained from the solution of the wave functions. Then what to do here is not only this first one you don't have a negative part of the curve, whereas the second one we have negative part, the third one we have negative part as well as positive part, both are there. To overcome this problem of negative value of this whatever the curves and all, we can do one thing, that square of the wave function we can write, means RNL we can write square, means size square we can take on the y-axis to overcome this difficulty. That is one point. The another point is nothing but in this the probability curves 2s and 3s, once you observe what I told, definitely in this 2s and 3s, whatever 2s here, this is 3s, has this is positive part is there as well as negative part also there. These objections what we can do, we will overcome by taking the square of the wave functions and writing this graphical representations. Okay, that we can do it. Okay, dear students, now you observe, I would like to write the graph between the square of the wave function and radius. Square of the wave function we are taking on the y-axis and radius on the x-axis we are taking. Why we are doing this one is to overcome the difficulty of the negative part of this representations of the graphs. So to overcome the negative part in the 3s and whatever 2s graphical representations, the previous discussion, we have to make the square of that radial part. So we did, and here we got some modification and some little clarity about this nodal planes also. So this is the node where this probability of finding the electron is 0. Here for 2s orbital we got one nodal node, and for 3s orbital we got two nodes in the graphical representations. We got these curves like this after finding the graphs, after drawing the graph between this size square and radius. Now can we believe this graph and the RNL? So RNL versus R radius and R square NL versus radius. These two graphs we just now observed, but believing these two graphs and deciding the probability density is completely wrong. Why? Because I am telling the maximum values is still coming at R is equal to 0 in these graphs also. That means there is no way this R values, R square values are telling about the probability density of this electron in the hydrogen atom or any one electron species like hydrogen like species. That means we have to modify this information to some extent where this problem can be solved. That means near nucleus you don't expect electrons. Above the nucleus, this means around the nucleus electron density is present. So in the next coming video we are going to do the one more advanced thing to completely overcome the difficulty what we face in this graphical representations. That is what the radial probability distribution curves by considering a particular volume around the nucleus and volume related. Volume is a volume as well as the probability density, both you take and you multiply, then we will get radial probability definitely around the nucleus with a successful representation of the Schrodinger wave equation. That we'll see in the next video. Until have a nice day. Bye bye. Thank you very much.